If you haven't met the quadratic formula by this stage, I wouldn't recommend you try this problem. However, you should be very familiar with the quadratic at this stage, so I wouldn't be too worried. A runner starts a 100-meter race in the blocks. She launches with an initial velocity of 3 meters per second. Her constant acceleration is 0.22 meters per second squared. Calculate her finishing speed and her finishing time. So this is a two-parter question. So go ahead and try this, and when you're ready, come back for the solution. So in two-parter questions, we don't like to use quantities we found in later parts. So what do I mean by that? So in this case, we found V first, but in part 2, we wouldn't want to use V in our formulae in case we get this question wrong, which would subsequently end up another question being wrong. So we want to make sure that the questions are sort of independent of each other. So this is our general SUVAT table. It's a 100-meter race, initial velocity 3. The final speed or finishing speed is V, acceleration is 0.22, and the time taken is T. So firstly, we're going to ignore T, so we have V squared is U squared plus 2IS. So V squared is 3 squared plus 2 times 0.22 times 100, which means that V squared is 53, or V is about 7.28 meters per second squared, or meters per second even, it's not meters per second squared. Secondly, we're going to ignore V, so we have S equals UT plus 1/2 AT squared. Substituting everything in, we get to this quadratic here. One of the answers will be negative. We know that it's going to be negative because the product of the roots should actually be T, not X. So the product of the roots, T1, T2, is C over A, so that's minus 100 over 0.11, which is like minus 10,000 over 11. So we automatically know one of the answers is negative, so we can completely discount that. So the finishing time is 19.5 seconds. As a bonus question, can you think of a modeling assumption that we've used here? And maybe why this particular mathematical modeling of this runner is not entirely accurate.